Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to continue looking at the law of sines, but this time we're going to deal with the side-side angle when using the law of sines. So let's get started. Now, again, I'm assuming that you remember how the law of sine works. Basically, when you have sine of A over alpha, or equals sine of B, sine of beta over B, sine of gamma over C, etc. We talked about that in a previous video. And so now what's happening this time is that in the last video it was angle, angle, side. Now we're doing side, side, angle. So here's our triangle here, our oblique triangle, and I forgot to add in that this is 80 degrees right here because this is our angle that we're going to use. And so we clearly have the two sides. We have length of B is 121 and A is 120, and then we got alpha here is going to equal 80. And now we need to figure out, okay, what are the other angles? And we could even figure out what the other sides are if we really wanted to. So let's go ahead and get started here. So I know this guy right here, sine of 80 degrees. So I'm going to go ahead and use that information. So sine of 80 degrees, and that's going to be over 120, equals, the only other thing I know is the side length of B. So I'm going to go ahead and put that in here. So that's going to be 121, but I don't know what sine of beta is. Beta, like so. And it's really simple. The first thing you do is you multiply both sides by 121. I mean, you've seen this before. And so now I have 121 times sine of 80 over 120 equals sine of beta, like so. Oh, whoa. Put this guy right here in parentheses. Okay, now the next thing that we need to do is we just have to figure out what is 121 times sine of 80 over 120. And so we use our trusty calculator for that. No need to guess it. So 121 times sine of 80, like that. And then we divide this, of course, by 120, and we get the answer of 0.99. So we're working our way along here. So go back here, change the color, and so you got sine of beta equals 0.99, what was it, 0.993. Now we have to find the inverse of this, so we take sine to the negative power of 0.993, like so, will give us our approximate answer. So I take this answer right here, I do the inverse, and I get the answer of 83.22 degrees. So that means beta is going to equal 83.22 degrees, like that. So beta is going to be up here. It's going to be 83.22. This is beta, like so. And then gamma will be down here. Now, of course, if we want to figure out what the length of gamma is, we just take 80 plus 83 to make it simple, and that's going to equal 163. And so then we do 180 minus 163, and we get 17 degrees. Because as you guys already know, I'm sure you're familiar with the fact that a triangle has 180 degrees inside it. So we know that gamma is going to be 17 degrees, like so. And if we really want to, I guess we could also solve and figure out what the length of gamma is, or I'm sorry, the length of C over here, because we don't know what it is. So let's go ahead and do that on the next slide. So we got sine, this is again 80 degrees, forgot to put that in here. This is 83 degrees, this is 17 degrees, and this is beta, this is gamma down here. So sine 80 degrees over 120 equals, let's see here, sine of 17 degrees, and we don't know what the value is. It's going to be C down here, C. So more of the same, multiply both sides by 120, and so I get sine of 80 degrees equals 120. Wait. Do I want to do that by C? No, I want to multiply both sides by C, excuse me. Multiply both sides by C, and then that canceled out, so then I have, what we need to do first is multiply both sides by C, and so I end up with C sine 80, hope you can see that, over 120 equals sine of 17. Now I multiply both sides by the reciprocal of C sine 80 over 120 basically, and so what ends up happening is I end up getting the following. If I do that, I end up with the following answer, and that is going to be, if you take a look at this, now I'm going to multiply both sides by the reciprocal of, we call it sine of 80 over 120. That's what I need to do. And so by doing that, I'm able to isolate the C term, if you will. So just to draw a line here so things look nice and clear, we're going to have C essentially equals, let's see here, it's going to be sine of 17 multiplied by, and I know I'm running out of space, so please be patient, of 120 over sine of 80. That's what we get. And so if I put that into the computer, so essentially I have sine of 17, whatever that is, sine of 17, and that's going to be multiplied by, it looks like it's going to be multiplied by 120 over sine of 80. That's what we got there. Let's see what we get. And so we get a length of 35. So the length of this gamma side here is going to be 35, like so. All right. So let me go back and review what we talked about, and we're going to conclude the video. So in this video, we talked about how to deal with a triangle when you're trying to find the length or trying to find the angle or whatever of a triangle that has, two sides and one angle. And so the process is explained right here in that basically you use the law of sines again, take what you know to find what you do not know, and then follow things appropriately. So this is all basic algebra right here, nothing new or unique about here. But when you finally get close to the answer, when you get the sine of beta equals whatever in decimals, you have to use the inverse of sine, arc sine if you will, to get the actual answer in terms of degrees. And so then on this page, we just tried to figure out what the last side was, and this is kind of when two angles and you want to find a side basically. So we kind of did this in the previous video, and we found out that this length was 35. It was kind of messy here. I ran out of space, but essentially, you set things up accordingly like so, and then you multiply both sides by C, but then you want to multiply by the reciprocal here so that you can cancel this guy out right here and isolate the C by itself. And then it's just a matter of just plugging it into the calculator. So I hope this was useful for you. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.